The template substitution side turns out to be much easier. Recall that we're going to have a group subst function that takes a syntax object that is a group form and an environment that we can use to substitute from. And so %x plus %y should turn into 3 times 4 plus 2 if x is mapped to 3 times 4 and y is mapped to 2. Similar to matching, group subst boils down to substitution on a term list. So let's consider that helper function. We've got a template, which is a list of terms, a list of syntax terms. If that list is empty, then we don't need to convert anything. We can just return empty. If it starts with an escape, we'll have to do some work. Otherwise, it doesn't start with an escape, so we can just keep that first term literally and recur to look for escapes in the rest of the template. If we do find an escape, then we can get the name, just like we did before. We can look for this name in the environment. So a name is going to be something like x or y, and we see if it's in the environment and mapped to a syntax object. If not, we complain, but if it is, then we can take that syntax object, turn it into a list because it represents a group, and append it to the recursion as we skip over the percent and the name, look in the rest of the template, convert all those things, and then just append them together. So that's all there is to term list subst. In the full code, it looks like this, where the group subst is just going to use term list subst, and group list subst really is a straightforward map. So that's all the code that we need for substitution here. Well, we do have to deal with the term levels where we might have lists or parens or quotes or block, and we have to recur inside those lists as well. Once we have that function, then we can use it in our interpreter. So the quote e form with a template inside is just using the group substitution with the current environment, because % signs can refer to any variable that's in our environment.